Hello, my name is Badru Senoga, and I'm here to present data visualization D3.js. We're using this project for the dataset I used is for water quality in selected districts in Uganda. This is a project that was conducted by a group of researchers, and they took different samples from different districts in Uganda, from different water sources. That is to say, the boreholes, the wells, protected springs, tap water, from all different regions in Uganda, the eastern, western, northern, and central. So we want to use their data set, the data set they collected at the end of it all, because they are comparing attributes that can lead to contamination of water, and then comparing it to confirm, or using that knowledge to be able to come up with better ways of handling poor quality of water, as well as finding doing more research to ensure that those factors, the measures that are below standard, they can be controlled in future. So briefly, this is the project. This is the link to the project. This is the data set that I used. It is available on the website. You can also download it and try out. And the code that I used at the end of it all, I shared it on my drive, so you can access it as well. So briefly, this is the standard for the different parameters that were used. The pH, which has to be between 5.5 to 9.5. Realized in the next slide, I did comparison of pH by source type in each district. So I used the source type, that is to say the tap, the first one tap, borehole, others, and protected spring. Then I was using it to compare different the different pH, sorry. So pH here, the standard one is 5.5 to 9.5. That is the range. So here, for the district of Jinja, there is a drop down here for districts, as we are going to see. When you go to Jinja, it was able to summarize only tap source, the water sources for tap, and it gave it a range from the lowest being around 2.1, then the highest being over 6.5. So as long as it is within the range of 5.5 to 9.5, it is okay. So we kept on comparing the same for borehole, then others. Remember, there are some districts that don't have set tap, or they don't have a certain source type. So that's what we are going to see afterwards. So another visualization I looked at. So this one is what we call the candlestick. This is what we call the candlestick chart, and it is the one that helps us to get the range between the range for the pH. So this is a radio chart which helps us visualize the different parameters that we talked about. And in the code, as we are going to see, I gave it different colors to represent how much it is, or how much it is the different parameters are distributed across the different districts. That is to say fluoride, sulfate, ammonium, how are they distributed in the water sources or water samples that were collected. So this is what I represented with a radio chart. And then I did a histogram whereby I was able to tell the number of water sources for each source type. So if the source type is tap, how many water sources were used in this particular testing, or in this particular experiment, or the research that was being conducted. So I was able to tell, when you move the cursor over the bars, you can see the numbers, as we are going to see from the other side of the presentation of the demo. So also I looked at the donut chart, whereby I saw the water sources distribution per district. So these are the different districts. I put them on the key at the side here, the different colors. So we realized this side of Lamo is a bit bigger compared to the rest, meaning we captured in this particular research, more water sources were used in this particular district, that is Lamo. Then the next one is, I see Nakaseke, also its size is a bit bigger compared to the rest. Apart from Lamo is the biggest. Then the next is Nakaseke. Then I see Kamori is also there, meaning they had more water sources where the samples were collected in this particular research. And this helps us because there's a reason where you'll see that certain things are happening, and then you will have to know, okay, why are we getting this? So now this is about the number of water sources per each source type. So how many water sources do we have in that particular source type? Let's say if we have a well, how many water sources or how many water sources comprise of what we call a well? So if we have taps, how many taps were used? How many taps did we get those samples from? If it is a borehole, how many boreholes did they go to collect these particular water samples? So we want to know how many water sources, but this time around we are looking at the type of source instead of looking at the district or where it was good, but what type is it? This is a water source, but is it a borehole or it is a tap? Okay, if it is a tap, how many taps how many taps were used for that particular water source to get those samples from? Because you have to get those samples from different taps to be able to get a very good, accurate observation at the end of the day. I also did a visualization of stack bar chart, whereby it combines it here we represented on the key I put all the parameters, water quality parameters here, their unique colors. Then at the side here, I showed the distribution of these parameters by water source, not district, but each particular water source. So that is what I specified. There are so many water sources, that's why even it goes down. So, but I tried to visualize it to see where, if you're looking for pH, you can tell where how much pH is on that particular water source. Briefly, that's it. That is the dashboard. So, and these are my references. So allow me take a look at the actual code. So this is my dashboard. So this is a standard, as we saw the slides. So here, in case I want to check for, this is a drop down. If I want to check for Bojiri, still it changes, as you see, it changes automatically. Mukono here, it shows that there are only two source types. There is a borehole and protected spring. The rest are not there. From that particular research that was done, so that is what we are looking at. And each has its own unique colors. So the color bit of it shouldn't confuse us. What we want most is the below part and then the highest part, so that we are able to tell the range. As long as it falls within pH 5.5 to 9.5, that means the water is of good quality when it comes to pH. Then for other attributes, let's say sodium, it has to be 200. If it's above 200, that means it is of poor quality, or it will contribute to that water being classified as water of poor quality. The same for other districts. Okay, so Mubende just has only borehole, and the borehole, if it is a borehole, what is the pH of that particular borehole? So here it is focusing only on the source type where that particular sample was got. Then for the water quality parameter distribution, this is the radio chart. This usually happens if a parameter occurs over a period of time, a cycle. Now let's say like nitrate, the way the quantity may change after a week or after a month. So you realize that it's a good idea you visualize it with a radio chart, and even the colors pop up. You can see, though right now they are a bit small, they are a little bit small, but as long as you see those that stand out, you can be able to tell which particular parameter stood out from the rest. Now with this number of, to know the number of water sources for each source type, the water sources are on the y-axis and then the source type are on the x-axis. We already know that tap is a source, is one of the water, one of the source type where the samples were gotten. So how many water sources were there? So you just move the cursor to the bar and you're able to tell that water sources, there were 8. That is for tap. Then for borehole, 61. Then other water sources, 48. Then protected spring, 12. Well, 30. NWSC, National Water and Sewage Corporation, then unprotected spring. So you are able to tell the number of sources where these samples were gotten from, and then you're able to go ahead and compare with the other attributes. So water sources distribution per district, the district is there, and you can be able to tell with the size as we saw in the demonstration. Now this is the final bit I wanted to look at or share, whereby we are able to see the distribution of all these parameters, water quality parameters, equally, pH, electrical conductivity, turbidity, color apparent, total dissolved salts, total hardness, magnesium hardness. So to tell all this, you're able to see at the bottom here, there is a parameter value. So we did not restrict in any way. I did not restrict in any way. It is from 0, it goes up to 500. So in case there are many more information that needs to be collected, we can always capture it from 0 up to 3,000, even more. So these are the different water sources. That is from the different villages, not the district, but the villages. From each and every point where the water sample was gotten from, it is visualized here, and these are the results that were gotten. If you refresh a little bit, you can see that it is moving, the animation bit of it, okay, which is a very good way of visualizing. And from my findings, I realized that fluoride, which has a standard of 1.5, there were 4 sample points which had over 1.5. Then for the nutrient, that is the standard, which is 0.9 nutrients. Then I realized there were over 18 sample points that had 0.9 and above. So meaning that if for those particular 18 sample points, they are not of good, they may contribute that water not being of good quality. So it has to be worked on. And then ammonium, the standard is 0.5. And then I realized there were 9 sample points that had over 0.5. Then sulfate, the standard is 0.7, but there was 2 sample points that were over 0.7. So there's so many other parameters or some other observations that we can derive from this, but the same idea of pH here, we can use it for other parameters. The same for distribution by water source. This time around, it can be by district. I see the same concept. We just have to change our code from our code for D3.js. So briefly, that's it from me. I do thank you. This is the dataset, the regional dataset from the different regions of Uganda. So I was able to clean this data into a better data set that I could use in the code. And briefly, that's it from me. Thank you very much.